Hello guys, how you doing? It's your online tutor Abu Michael aka Abu Miki. I'll be taking this short one is on photoelectric effect or photoelectric emission. If you look at my screen, you will see that I have a kind of solid object right there, and we have green balls being knocked off the solid object, and we have a blue-like wave-like arrow coming on the solid object. Well, the solid object is actually a metal. The green ball are electrons, and the blue wave-like arrows are actually electromagnetic radiation. If you like, you can just call it light. The idea or the concept behind this whole thing is when this electromagnetic radiation falls on the metal, then electrons will be ejected from the metal. Now that simple thing is called photoelectric emission. The only thing that wasn't captured in this diagram will be that electromagnetic radiation or the light must have enough energy to be able to knock off the electrons. Now this is another diagram that depicts that same information, where these green arrows are actually representing the electromagnetic radiation and the orange balls are representing electrons being knocked off the metal. So if you ask us to define photoelectric emission, I will combine everything I've just captured with the diagram and with what I've said. It will mean that photoelectric emission is the release of electrons from the surface of a metal when light or electromagnetic radiations or sufficient energy is incident on it. So the light needs to have enough energy before the electrons can be emitted. Now the same thing happens with thermionic emission, except that for thermionic emission, I will need heat to be applied to the metal before electrons will be ejected. Now Albert Einstein actually gave us an equation that captures the energy of the photon, the kinetic energy of the electrons, and the metal's ability to release those electrons. So this equation can simply be written as this: HF is equal to psi plus half mv squared. HF is actually called the energy of the photon, while that psi symbol, the Greek symbol, is called the work function, and the half mv squared, you know as a physics student that's kinetic energy. Alright, so the energy of the photon is equal to the work function plus the kinetic energy. This is Albert Einstein photoelectric equation. Well, we need to define what work function is. So if you check my screen, you will see that I have given you a definition for what work function is, so that when you are writing your notes, it will be kind of easy to write your notes. So very quickly you can write that down as I scroll my page. Now if you check, the work function has the formula HF naught. Now it will interest you to know that the F naught in the work function is not the same thing as the F in the energy of the photon. The F in the energy of the photon refers to the energy of the incident radiation, or the incident light, or the incident electromagnetic radiation, depending on what you are looking at contextually. But for the F naught, it represents the threshold frequency, and that will be a property of the metal. The threshold frequency, you get it? So F naught is the threshold frequency, and threshold frequency is the minimum frequency required to release electrons from the surface of a metal. It will interest you to know also that when these electrons are being ejected, their kinetic energy is solely dependent on the frequency of the incident radiation, not the intensity of the incident radiation. This is that part of physics that debates or debunks some of the things we know in classical physics. So please, the kinetic energy of the electrons is dependent on the frequency of the light, while the number of photoelectrons depends on the intensity of the light. I call them photoelectrons, and that is how it is being called, like generally, because the electrons are released as a result of light photo, so we call them photoelectrons. Well, that will mean that you can still define photoelectric emission as the release of photoelectrons from the surface of a metal when light or sufficient energy is incident on it. It is good that we know the application of photoelectric emission. Now we can use photoelectric emission for quite a number of things. One of them is the photocell, the automatic doors, automatic windows, the solar panels, photostatic copying, can use for light meters, electric eye door openers. The application are actually much. Many times, if you are writing Nigerian exams here, talking about the WAEC, the NECO, the GCE, they do highlight the solar panel and the photocell as areas where questions are being asked for, especially the photocell. So it is good that we all know what the photocell does. And let's say, for example, you are asked, what are the applications of the photocell? You may still write these applications down, but you will not include the parts of the photocell. You can just say, you can write automatic door opener, photostatic copying, solar cells, light meters. You can just write them like that, but no photocell. But if you are asked the application of photoelectric emission, you can add it can be used in the production or in the manufacture of a photocell. Now it's good we know the simple structure of a photocell, which I will show you very quickly. This is how a photocell looks like. If you check my diagram, you will see that there is a C symbol there, an A symbol there, then we have light coming in to the C symbol. Or actually, the C and the A are electrodes. The C is the cathode, while the A is the anode. The C cathode is acting as an emitter, while the A cathode, the anode is acting as a collector. So what happens here is the cathode collects the incident radiation or incident light, then it releases electrons which are attracted to the anode. You get it? So very, very, very simple. Now this diagram have been presented many times, 2 or 3 times in our WAEC exams, where you have to label those points. Now the whole glass, this whole setup is in a glass tube. So if you are asked to label that part where the black line covering the C and the A, that is your evacuated glass tube. Yeah, that's your evacuated glass tube. So your cathode functions as an emitter. That is, it is the part that releases the electron to the anode. The anode acts as a collector. It collects the electron that will be released from the cathode. Then the incident ray falls on the cathode. You may discard the parts that has to do with the battery and the ammeter, showing that little amount of current is passing through. Well, actually, when you set up a photocell, little amount of current will pass through, because that's why when you check people's houses, those guys that have solar panel, you will see an array of solar panel, quite a lot of them, so that you can be able to deliver enough current. Now, in my next video, which I'll be showing you soon, I'm going to highlight some questions, then we're going to solve them together. If I feel I will not be able to use this kind of presentation, then I'm going to use a whiteboard to show you how to go about the workings, the solutions, answer questions, so that your confidence level will increase. I'll see you guys in my next class. Thank you very much.